Hi everyone, this is the help video for the 5.01 quiz review on proportional relationships found in graphs, equations, and tables. So in this situation, we are going to be discussing determining graphs and equations and tables and if they are a proportional relationship or not. So at this time, please make sure that you either have your quiz open or that you are awaiting another attempt to be open. And if you need any help with that, you can reach out to your teacher. Here's the first question. Which of the following equations represents a proportional relationship? Now, in order to answer this question, it's super important that we understand the formatting of an equation of a proportional relationship. So as we can see in this little box here, a proportional relationship will always follow the equation format of y equals kx. Now, this is super important. We talked about this in whole group, so if you didn't catch this part, you can go back to the recording and watch what we discussed. But we keep this standard format because this equation is what keeps our graph looking proportional. And as a reminder, in order for a graph to be proportional, it has to be linear and it has to pass through the origin. So the issue with adding 3, for example, to an equation is now it's no longer touching the origin. So A cannot be an answer because this is not following our format of y equals kx, where k can be any value. Let's look at B, y equals 5x. So far that one looks good. We're not going to cross it off. It does follow our format of y equals kx, where k can be any number. Let's move on to C. C is y equals x squared. Well, if anything is squared in a graph, we know that that creates a bend in our graph, which means that's not proportional. So we're going to get rid of this one. We know that it cannot have anything being squared on our equation. And then finally, D is x equals 9y plus 4. There's multiple issues with this one. The first is that it's x equals and not y equals. So that's a problem. And then we have this positive 4, which is also a problem because that means it takes it off of the origin. So the answer to this one is y equals 5x. Again, it follows the formatting of our formula of y equals kx. And now we can go to question number 2. Question number 2, what value can you place in the empty box to make this a proportional relationship? So in order to create a proportional relationship, I am going to set up a proportion. I have 4 over 20 equals 5 over the unknown value. So we're trying to figure out what value can be put in here. It's also important to notice that you don't have to choose 4 over 20. I could have also chosen 6 over 30 or 7 over 35. Any of those would give me the same answer. I just started with 4 over 20 is equivalent to 5 over my unknown value of x. So I'm going to go ahead and try to solve this by using some cross multiplication. Now, there are a few different methods of solving, but cross multiplication is going to be the most accurate method. So 4 times x is 4x. 20 times 5 is 100. Now I have a one-step equation. I can isolate my value by dividing by 4, and this leaves me with x equals 100 divided by 4 is 25. So the unknown value in my box would be 25. So again, setting a proportion and solving for that missing value, I was able to find the unknown value in the table. And now question number 3. Question number 3, we did discuss this previously in question 1. We'll just go over it again. The characteristics of a proportional relationship in graph form. It comes in 2 different qualities that we need to look out for. The first quality is that it is linear. So that means it has to be a straight line. There can be no bend in it. So if we look over at our graphs in the purple side, we see that one of these graphs has a severe bend in it. It's actually called a parabola. It's not a straight line. So this cannot be proportional because it is not linear. The second important quality is that it passes through the origin, which is the point 0, 0. And so that idea of passing through the origin is also very important, similar to why in equation form we cannot have anything added or subtracted to our equation. We can see that in our graph over here, although that second line is a straight line, so it is linear, it's not passing through 0, which is important. So this is an example of proportional versus non-proportional. Again, those two qualities, it has to be a straight line, so it has to be linear, and it has to pass through the origin, which is the point 0, 0 on the graph. Next, we have question number 4, and question number 4 asks us to choose the table that shows the proportional relationship. And we do have a little reminder at the top that we can use k equals y divided by x in order to find the if a table is proportional or not. So what we're going to do is we are going to view all of these as little division problems. So we're going to set up all of these, and what we're looking for in a proportional relationship is consistency. So we've got table number 1 and table number 2. So using that formula of k equals y over x, I'm going to take this first table. My y value is 4, my x value is 2. So I have 4 over 2, which equals 2. Next, I have 8 and 4. 8 divided by 4 is 2. Next, I have 16 divided by 8, which is 2. And then I have 32 over 16, which is 2. So we can see here that there was a consistent relationship between y and x of a value of 2. Now I'm going to do the same thing with my second table. And we're going to see if this one also has a consistent relationship between the y and the x values. Using that same formula, k equals y over x. 6 divided by 2 is 3. We have 7 over 3. 7 over 3 doesn't divide super evenly. I can go ahead and plug it into my calculator to figure out what the decimal version would be. 7 divided by 3 is approximately 2.3 repeating. Next, I have 12 over 4, which is 3. And then I have 14 over 5. Again, I'm going to use a calculator for that. I don't know it off the top of my head. 14 divided by 5 is 2.8. So now what we can do is we can look at what the relationship is on this second graph or on the second table. So we've got 3, 2.3, 3, and 2.8. That's table 2. Excuse me. And then we'll look at table 1. We've got 2, 2, 2, 2. So which of these tables has a consistent relationship between y and x? Well, the answer to that would be table number 1. We can see that no matter what the y and the x value is, that relationship between them remains 2. So that's the proportional relationship. 2 does not have a proportional relationship. There are different values in all of the relationships, 3, 2.3, 3, 2.8. So our second table, 2, is not a proportional relationship. And finally, question number 5. What are the different ways that a proportional relationship can be shown? So, this question is really asking you to just wrap up all the information that you learned during this lesson. So, the different ways proportional relationships can be shown. First way would be equation form, and it would be in this format, y equals kx. Second form would be in table form, where you compare the relationship between x and y and make sure that you have a consistent relationship in the table. And then the third way would be in graph form, making sure that your graph is linear and that it passes through the origin. So that wraps up our quiz review. You can use this video to help you prep for your quiz. Make sure that you also look for the notes that are posted. And as always, if you need any help, feel free to reach out to us. Thank you for watching.